Here we have a SAT math problem. Okay, let's cover the question. Y equals to negative 2x square negative 40. Y equals to px positive 10. In the given system of equations, p is a constant. The graphs of the equations in the given system intersect at exactly one point x comma y in the xy plane. Which of the following could be the value of x? Okay, here when I solve the system of two equations, I'll be getting the points of intersection of the graphs of the given equation. So here the question says x comma y is only one point of intersection of the graphs of the given two equations. Now we have to get the x coordinate at the point of intersection. Okay, for that we have to solve the given system for the value of x. Okay, now let's equate y and y. And for the y on the left side, let's consider the stuff in the second equation. Then I'm getting px positive 10. And for y on the right side, we can consider the stuff in the first equation, that is negative 2x square negative 40. Here we get a quadratic equation. Let's get this quadratic equation standard form. Standard form means ax square positive bx positive c equals to 0. That is, we have everything on one side of the equation, on the other side 0. Okay, let me add 2x square to both sides of the equation and also add 40 to both sides. Let me do it. Then this negative value, positive value will cancel out. The same here. We have 2x square positive px. When I combine positive 10 and positive 40, I am getting positive 50 equals to 0. Okay, here if I want to solve for x in this quadratic equation, I must be knowing the value of this unknown constant p. And I got this quadratic equation by solving the given system of equations. Since the question says the graphs of the two equations in the given system intersect at exactly one point, I'll be getting only one solution for this quadratic equation. When we have a quadratic equation standard form, that is ax square positive bx positive c equals to 0, and there is only one solution for the quadratic equation, then the value of the discriminant b square negative 4ac will be equal to 0. Since this quadratic equation has only one solution, the value of this discriminant b square negative 4ac for this quadratic equation will be equal to 0. Let's get the value of this discriminant b square negative 4ac. Okay, for b we have to consider the coefficient of x. Here the coefficient of x is p. Then we get p square negative 4 times a is the coefficient of x square. Here the coefficient of x square is 2 and c is a constant term. So here the constant is 50 and it must be equal to 0. And p square negative, the product of 4, 2 and 50 is 400 equals to 0. Okay, let me continue here. Let me write the same equation. P square negative 400 equals to 0. Let me add 400 to both sides of the equation. Then this negative 400 positive 400 will cancel out. I'm getting p square equals to 400. Now let me take square root on both sides of this equation to get rid of the exponent 2. And here the square root and square will cancel out. Usually when we take square root on both sides of an equation, one of the square roots will cancel out. And for the other square root, we have to consider positive or negative sign. Then we get p equals to positive or negative. Square root of 400 is 20. We get two values for p. One is p equals to 20 and the other one is p equals to negative 20. Okay, now let me consider the graphs of the two equations over here. The first one is a quadratic function, and usually when we have a quadratic function in the form y equals to ax square positive bx positive c, its graph will be a vertical parabola, and here the leading coefficient, that is the coefficient of x square, is negative 2. So that's a negative number. Since it's a negative number, the vertical parabola we get for this quadratic function will open down. So this is a graph for the first one. And the second one is linear and it's in slope intercept form. And here p is the slope of this linear equation. And we got two values for p, 20 and negative 20. When I take 20, positive 20 as a value of p, I am getting a positive slope for this linear equation. Then its graph will be a rising line. Then we'll have the line over here like this. Okay, now when we have a rising line, the line and parabola will intersect at only one point according to the information. What if I take p equals to negative 20? When I take p equals to negative 20, the slope will be a negative value. Then I will be getting a graph as a falling line for the second one. Then we'll have a line like this. So again, the graphs of the two equations intersect at only one point. But we cannot have both the values simultaneously for p. Either we can have 20 or negative 20. Only one of the values of p can be considered. Okay, let's consider the positive value 20 for p. Then this equation will become 2x square positive 20x positive 50 equals to 0. What if I consider the second value of p, that is negative 20? Now we have to plug in this negative 20 for p over here in this quadratic equation. Then I'm getting 2x square negative 20x positive 50 equals to 0. Okay, here when I consider both the equations, all the terms on the left side over here are multiples of 2. The same thing we have in the second equation as well. So let's divide each term of the first equation by 2. Then I'm getting x square positive 10x positive 25 equals to 0. Let's do the same thing over here. Then we get x square negative 10x positive 25 equals to 0. I think this quadratic equation can be solved by factoring. For that, we have to multiply the constant term positive 25 by the coefficient of x square 1. 1 times positive 25 is positive 25. Now we have to get two factors over here so that the product of two factors equals to positive 25 and the sum of the two factors equals to the coefficient of x positive 10. I think positive 5 and positive 5 will work. Further, we have to divide both the factors by the coefficient of x square 1. Still we get positive 5 and positive 5. Since we get the same factors over here, we'll be getting one solution for this quadratic equation. To get that one solution, we have to change the sign of the factor over here. Already it's positive 5. When I change the sign, it will be negative 5. Now let's solve this quadratic equation by factoring. Multiply the constant term positive 25 by the coefficient of x square. Then I'm getting positive 25. Okay, now we have to get two factors over here so that the product equals to positive 25 and the sum of the two factors equals to the coefficient of x, that is negative 10. Then we get negative 5 and negative 5. When we multiply negative 5, I'm getting positive 25. When we add them, we get negative 10. That's a coefficient of x. Further, we have to divide both the factors by the coefficient of x square 1. Then we get negative 5, negative 5. Okay, here we got two same factors. We'll be getting only one solution for this quadratic equation. To get that one solution, we have to change the sign of this factor, that is a positive 5. Okay, here I got two different values for x. One is negative 5, another one is positive 5. And the question says the graphs of the equations in the given system intersect at exactly one point. So we can have only one value for x. So can we consider both the values of x? No, we cannot consider. We can consider only one of the values of x because we got two different values for p equals to 20 and p equals to negative 20. So that's why we got two different values of x. Only one of them is possible. So when I go over the answer choices, I find this value negative 5 in answer choice B. So negative 5 could be the value of x. The correct answer choice for this question is B.